So considering this problem here, I took the liberty to model the situation with a rectangular tank. And based on the directions, they said that the base is a square and the dimensions of that square are s by s. Suppose that we call the height h, and it is an open lid, so there's nothing in the top. Now the discussion here is about the surface area. Recall what surface area is. Suppose I wanted to gift wrap this box of Kleenex. Surface area is when I take the area of this rectangle plus the area of this rectangle plus the area of this. You see, I have to take all of the sides of this solid, take the areas of all the independent sides of this shape and add it together. That is the surface area. So here for this problem, let's calculate independently the areas of all of the faces. So this shape, it really has one base and it has 4 walls, where the base is the object on the bottom. That's what's resting on the table. And what is the area of that base? Well, the base is a square, so it's just s times s, which is s squared. What about the 4 walls? Each of these walls is like a rectangle. You can sort of see this rectangle here. What are the dimensions of that rectangle? It's s by h. So the area of this one rectangle is sh. But how many of these rectangles, of those walls, do we have? We have 4 walls, the 2 here and the 2 there. So the 4 walls together gives us 4 times sh. That is the area of the 4 walls. But all together, the surface area, I'll just call it surface area. The surface area of this would be the areas added together. S squared is the base plus 4sh, which is the 4 walls. We do not count the top because they said it was an open box. So this is our surface area. However, we have to also consider the volume. They said that the volume of this shape is 16,384. Now, how do you find the volume of a box? You basically go length times width times height, right? Even though the top is open, that doesn't matter. The volume of a rectangular prism, a box, length times width times height. So volume can be replaced by length times width times height, which is s squared h equals 16,384. That's a true statement, and so is this. We have 2 equations. Now here's the thing. I think they want us to give them, one of the parts of the problem, they want us to give them the objective function. The objective function is this one here, because in the directions, what is the overall goal? To minimize the surface area. That is the secondary equation. This is the primary objective function. So we cannot type this in as the answer because there are 2 variables. We have to deal with h. H has to go away because, to be perfectly honest, we created the h. The directions never mentioned h. They only mentioned s. So what you do is you isolate h and the other problem. Let's divide both sides here by s squared. That'll tell us that h equals 16,384 over s squared. And by substitution, this bubble, which is h, can go in right there. So we have surface area equals s squared plus 4s times whatever h is, 16,384 over s squared. And we can actually clean this up a little bit. This is s squared plus, that's a 1 in the bottom. You can go 4 times that number. 4 times 16,384 is 65536. And that s can reduce with s squared to just get s. Now, in an advanced class like yours, you can, if you want to, take 2 terms and turn them into 1. So the denominator is 1, so we get a common denominator by multiplying by s to make the denominators to match. And now we can take 2 fractions and turn them into 1. So this is our numerator and this is our denominator. This is the objective function, which I called SA, but I think if you look on their directions, I think they just called it A. So let me just box this in and declare that the objective function. Now, the interval of interest has to do with the variable S. What can S be? What can S not be? Well, what does S represent? It represents the dimension or the side of the square. For sure, S cannot be negative because you can't have a square with a negative side length. Nor 0. It wouldn't make any sense. It wouldn't exist. So S for sure has to be positive. It has to be bigger than 0. But is there some sort of upper limit to how big S can be? There is. Because recall, the volume of this shape is that. So the volume here, which is that times that times that, is exactly that and no bigger. So I know that we labeled it SSH, but let's just pretend that it's SSS. So that S times S times S, the volume, cannot be bigger than this. S times S times S can be at most this big. So here's the statement that we get. S cubed is less than or possibly equal to 16,384. And now you can cube root both sides. So on my calc, I take the cube root. It's a strange decimal, so I'm not going to use that. I'm going to use the exact value. So here I'm going to say that S can be at most the cubic root of 16384. So it has to be bigger than 0, but at the same time less than or equal to this. So as an interval, the interval of interest, I'd say would be 0 all the way up to the cubic root of 16384, where this is included, but that is excluded. So I submit that this is the interval of interest. So now for the last part, we want to find the height and we want to solve for S and H basically. Now recall that the overall agenda was to minimize surface area. As soon as you hear the word minimum or maximum, you're pretty much going to find a derivative, the derivative of the objective function. So let's write that down again. And now we want to find the derivative of A, so that would just be A prime. And let's apply the quotient rule, where it's the bottom times the derivative of the top, which is just 3s squared, minus the top is this here, times the derivative of the bottom, which is just 1, over the bottom squared. And we can clean this up a little bit. So this is our first derivative. And now we want to find the critical points. Critical points are whatever make the first derivative either 0 or undefined. So to do that, you independently set the top and bottom equal to 0 and solve. Solve both equations and you'll get that S equals 0 and S equals 32. These are the critical points of F. They are the undefined value and the 0 value of the first derivative. And what you do with these critical points is you go to a number line that represents A prime, and you make some cuts at those locations. And what you do is you pick test numbers that live in these regions. For instance, what's between 0 and 32? How about the number 1? What's on this side of 32? How about 33? Pick a number that's here, -1. And what we do is we take these test values and we plug them into the first derivative only to see if you get back something that's positive or negative. If you take -1 and if you plug it into the first derivative there and there, try that if you want, you will get back a negative number. Now, if you plug in 1 into here and here, you will get back a negative number. And if you plug in 33 in there, you'll get back positive. So the first derivative goes from negative to positive at the number 32. What does it mean when the first derivative goes from negative to positive? That means that your slopes go from negative to positive in the graph of A, which means that your graph possibly looks something like that at 32, which makes this a minimum because it's the lowest point because you go from down to up. You go down to up because the first derivative goes from negative to positive in its sign. So at 32, we have our minimum value. So all of this works when S is 32. So let's write that down. S has to be 32. That is the number that satisfies all these conditions. And that lets you know the dimensions of the square. This shape has a 32 by 32 base. So that would be our square base. So that's 32, and that's 32. The only thing you have to do now is find h. Why don't you take s as 32 and drop it into the little bubbled equation there, which should be 16. So the dimensions of this shape are 32 feet for the base and 16 feet for the height.